Well, good morning, everybody. Hopefully you can see me okay. Please, if you can, say something in the Top Hat chat. That would be really helpful. If you can say that you can hear me and see me. Oh, I still see people just typing hi. Lots of highs, which is excellent. Hi. Okay, people can hear/see me. That should also give me an idea of approximately how much latency I should expect between when I speak, when I can expect that you will have heard me. So, thanks very much for joining me today for Engineering 1020. So this is the very first lecture, and I have to say, your lab instructor and I were really looking forward to getting back in a classroom after 2 years of this online remote lecturing stuff. It has not been easy on you, and it has not been easy on us. Unfortunately, that isn't the way that it's going for the moment, but the plan is still to get back into a classroom. We'll see whether or not large classes like ours go back to a lecture theater, but to get back into a classroom for a lot of classes in February. And in this course, we are planning to still meet you in person in the labs. So, fantastic. People are saying, hearing you good, crystal clear, excellent. Super. Okay, so let us begin. So my name is John Anderson, Dr. Anderson, and I am I'm the course instructor. So I'm going to be doing lectures and assigning assignments, and I'm also going to be giving you exams. Ooh, nobody likes exams, but oh well, sometimes we have to have them. And then we also have Lori Hogan is the lab instructor, and so she'll be running the labs and coordinating the TAs who mark the labs and all that kind of good stuff. And we're a team. We've done this a few times before, so hopefully we've been making lots and lots of improvements to the course along the way over the past 6 years. And so hopefully you'll have about as smooth about as smooth as you can have an experience in this kind of environment where we're all sort of still not sure how much more we're going to need to pivot, and are we going to have to stand on our left foot tomorrow and our right foot the day after that. We'll see how it all goes. But the first thing that I would like to ask you is, why are you here? And actually, you know what? That's not quite right. The first thing that I'm actually going to ask you is not why are you here? I'm going to ask, where are you here? That doesn't quite work. So I'd like to know, where is here? So, if you've signed up for Top Hat, and if you've got Top Hat open on some kind of a device, and lots of people typing in the chat, so you should be able to answer this question. What is your time zone? I'm going to present this question now, and so you should be able to see this, hopefully. Actually, I might need to move it over here. There we go. That's probably a little better. Take myself out of the picture for the moment. All right, so this is an interesting question because in the past, well, obviously in the before times, a couple of years ago, everybody was in the room, so I didn't need to ask this question. Last year, people actually took Engineering 1020 from all over the world, and so I got quite a diversity of responses on this particular question. This semester, things are a little bit different. Hopefully you can see in Top Hat has a question popped up for you. So people are typing in the chat, which is good, but what I'm really looking for is for you to respond to the Top Hat question. And you can see 5 out of 58 people have done so far, and more people are signing in. So now it's 9 out of 61. So do answer that question in Top Hat. This is going to be part of the interactive nature of the course. We're going to kind of go back and forth. I'm going to present lecture material to you. I'm going to talk to you. And then you're going to do things like answer questions for me so that I can have some idea of how well you understand the material, but this is also an opportunity for you to give me feedback. And this back and forth is going to be a regular part of the course. So yeah, I'd like to know where people are, because you might not all be in Newfoundland at the moment. So you should have received an email from the Associate Dean of Undergraduate Studies saying that you will be, so you can only respond in a number. Absolutely. So if you see in the question here that's being presented, I'm looking for a time zone as a number. So for example, Newfoundland time is 3.5 hours behind UTC. So its time zone can be written as negative 3.5. So maybe if you are in Beijing, I think you'd be +8, something like that. If you were in Toronto, you'd be -5. San Francisco, I think, is -8. So lots of options here. But yeah, so please give that as a number. But so most people are probably in Newfoundland at the moment, and you should have received an email from Dr. Peters saying you have to be able to commute to campus. Now, there might be some people who are stuck because of pandemic travel stuff, who are stuck and who are not in St. John's at present. But you ought to be, if not on the way to St. John's, then hopefully having a plan to be on the way to St. John's. If you are not in St. John's, you need to let me know so that we can figure out how much adjustment needs to be made. At some point, we're going to get back into a lecture theater. Now, even when we do get back into a lecture theater, the lectures will be recorded, so you can watch them after the fact. But we are going to have labs, and we're going to expect you to show up to labs. Not just we're going to expect you. The experience will be so much richer for you when you are in a lab where there are people who are immediately there to help you and that kind of thing. And so that's something we are going to expect, but also we're going to have midterm exams, and you need to be here. If you don't write the exam and you don't have like a really extenuating reason, such as I'm not in Newfoundland because I'm somewhere else due to a death in the family, or something important like that, if you don't write the exam, you don't get credit for the exam. And so you want to get credit for your exams. Okay, we've got at least one person who is in Doha, +3 GMT. That's cool. But hopefully you have at the very least, and I recognize, I think, a couple of these names, hopefully you've already reached out to me and let me know, but hopefully you have at least a plan to get to St. John's. But if you're not here right now, do make sure you send me an email so that I know how many people aren't here, and we can try to figure things out accordingly. All right, so I'm going to close that question and take a look at some of the responses. And yeah, the vast majority were -3.5. Okay, somebody's in Eastern time. Somebody's in -330. I guess that was an attempt to write -3:30. And we've got a couple of people in +3.5. I think that's Iran, maybe. Okay, +4. Okay, someone in +11, and then we've got some other thing. Oh, maybe somebody was trying to write it's 11 o'clock for me, or it's 11:05. Okay, so let's get back to things. So I've asked you, where are you? But now I would also like to understand, why are you in this course? And there are a few possible answers. And sorry, let me just launch this again. First lecture is always slightly rougher than the other ones, especially when I'm using a configuration of technology that is slightly different from any configuration that I've used before. I've never used exactly this specific set of tools before. All right, so let us ask you why you are here. So why are you taking this course? There are lots of possible reasons. Some answers starting to come in. So perhaps you're taking this course just because you have to. And, you can choose, I believe I've set it up here, so you can choose more than one answer. And so if part of the answer is, well, you have to, then that's fine. But there are other reasons why you might be taking this course, and hopefully some of them are are a little bit more voluntary than just I'm doing it because I have to, but we'll see. And by the way, my plan, if anybody is watching this asynchronously, so some people just aren't able to watch it at this exact moment, in fact, because at least one student is in the midst of travel to St. John's. So if you're watching this on YouTube after the fact, I am going to open up the questions as homework that can be answered sometime in the next few days. So I think like by, I'll give you to the end of the week or something like that. So if you answer it synchronously, that's great. If you don't answer it synchronously, you'll have like until the end of the week to answer it. All right. Most people have responded, so I'm going to close this in just a few more seconds. And here's something that'll be really helpful. I'm going to time something. So I'm going to say a word, and then I want you to type the word in the chat as soon as you hear it. So let's pick a short word, and the word will be cat. There's a question there. How do I put more than one answer? If it's only letting you put one in, then you can just pick whichever one is maybe the most applicable. Okay, so that was about 2 seconds. No, sorry, that was about 10 seconds. Okay, good to know. It's good for me to understand the latency so I can not close questions too quickly. I will close this one now, however, and we will look at the responses. And yeah, so the plurality was that you have to take the course. That's fine. But also some things like I want to understand computers better. That's good. Programming seems to be important. It sure does. In some cases, I enjoy programming. That's good. So do I. And I hope that for those who came to this course thinking I do not enjoy programming, I don't want to do it, or possibly I'm a little scared of it. I don't know if I can do it. I hope that will convince you in this course that actually programming is something that you can do and that is worthwhile for you beyond just the requirement of what you have to do. So many cats in the chat. Meow. Okay, cool. Cat in the chat. That almost sounds like a cat in the hat or something. You have to... Okay. So why should you study programming? So for one thing, because you have to. But, people are interested in programming for lots of reasons. In some cases, people have noticed that software is a key career enabler. There are sectors of our economy that are massively growing that rely on things like developing software. So some people are interested in programming because it'll help their career or because they want to start a business. And there are lots of student entrepreneurs that we talk to and things. But also there are lots of students who are interested in changing the world in a broader sense. Not all entrepreneurship is about making money. There are social entrepreneurs who I work with. I've worked with a group of students in the past who were developing software to help coordinate amongst food banks in Newfoundland with the sort of like, there's this like super food bank, and it's like a food bank for food banks that can arrange for food to be at all the various food banks when they need it, but they don't want to ship too much to any one place because you don't want anything to go to waste. Well, there are tools that there are software tools that can be written that can help coordinate that process and make it more efficient so that the right food ends up in the right place with less wastage, that kind of thing. So for some people, it's about changing the world in the sense of starting a business and employing people and making money and having an impact in that way. For some people, it's about being more socially entrepreneurial. In some cases, it's just about finding a cool career where you get to solve neat problems and work on important stuff. There's all kinds of reasons. Oh, I see a cat emoji in the chat. So that is your lab instructor, Laurie Hogan, and that is some next level stuff right there. Excellent. But it's not just about, your career. Part of the reason why you need to understand programming, or you need to understand in some level computing, is that you are responsible for the things that you do as an engineer. So when you graduate and eventually become a professional engineer and you do stuff, whether it's in civil engineering or mechanical engineering or computer engineering, you are responsible for the stuff that you do, even if computers are an important part of what you do. it is not an excuse, or it's not a legitimate excuse, to go to a regulator or a professional discipline committee and say, well, sure, the thing I designed collapsed and hurt a bunch of people, but, it was the software's fault. I used software and the software was wrong, so it's the software's fault. That is actually not good enough. So there is a sense in which you can't really understand how the world works these days, because we live in a digital world, unless you understand something about the way that computers work and the things that they are capable of and the things that they are not capable of, and the circumstances in which computers do things well and the circumstances in which they do them poorly. Oh, I'm getting so many different emoji now. Excellent. Oh, yes, we even have crying cats and heart cats and shocked cats and dogs. Oh, a lion. Very nice. So there's a sense in which we can't understand the digital world without understanding something about computing, but also engineers are responsible for their use of computers. Just like, so I said, you can't just blame the software. That would be like blaming your calculator. My calculator didn't work, therefore it's not my responsibility that the bridge collapsed. No, that's not the way it works. So we have to understand something about computers and something about software so that we can figure out how will we gain confidence that this software is actually working correctly. Another thing is that programming is a really important method of problem solving. So in Engineering 1, you're going to be exposed to lots of different ways to solve problems. Some will involve graphical representations, some will involve mathematics, some will involve setting up systems of equations and solving them. And programming teaches you an algorithmic way of thinking about problems, which comes up in every single engineering discipline. So learning programming will teach you a mental discipline that helps you think in a more structured and it help you think in a more structured way about solving problems and representing things. So you might think that if you're in first year and you don't want to go into computer engineering, which is fine, it's fine. I'm not going to take it personally. It's okay. You might think that if you're not going to go into computer engineering, that you're done with programming from now on. But nope. Statistics would beg to differ. Fluid dynamics would beg to differ. Doing seismic analysis of underwater oil reserves by setting off explosions, recording sounds, and then doing sophisticated analysis on that would tend to differ. Even using spreadsheets, and there's a good way to use spreadsheets and a bad way to use spreadsheets, and understanding something about how software ought to work can help you not write the spreadsheet that ruins everything. But what do I mean by that? There are examples in which people have made decisions that have a huge impact on the lives of people around the world who made their decision based on an analysis in a spreadsheet that turned out to have a wrong equation. And they came to the wrong conclusion. And they made huge decisions that had massive impacts on individuals living around the world because their spreadsheet was wrong. So that comes back to that responsibility thing again. And of course, programming can be a lot of fun. You may not believe me yet. Some of you do. At least 10 of you do. I know. But some of you may not believe me yet. But actually, it can be interesting to take a new problem-solving approach and apply it to new problems and solve those problems. It really can. And so here, let me just put myself away for a moment so you can just read this. Nice. Someone's got a construction worker emoji in the chat. I like that. Oh, we've got a duck. Oh, an angry cat. Oh, I hope we're not angry about programming. Maybe by the end of the course, we'll turn that angry cat into either the mischievous cat or the happy cat. All right, so I'm going to leave this comic for now because, well, unfortunately, we don't have all day. But you're very welcome to come back and look at it later. Or alternatively, if you just Google dinosaur comics Sherlock Holmes, well, you'll find a gazillion of them. But at least this one has to do with computers. Okay. So what are we going to do in this course? Well, we're going to learn how to solve problems with software. So these are the outcomes for the course. These are the things that you ought to be able to do by the time you successfully complete the course. And what do you notice about these outcomes? What do we see when we look at these course outcomes? Yeah, there's a slightly awkward pause where I've got to wait 10 seconds before answers start coming in. So one thing I could say that we should notice about these learning outcomes is what we don't see. None of these outcomes say anything about a specific programming language, like, for example, Python. This course is not about how to program in Python. Now, we will use the Python programming language, but this course is about how to think programmatically. So you should be able to take the things that we learn in this course and bring them to all kinds of other programming languages. Oh, I noticed there, by the way, my face is blocking out propositional logic. So why don't I put my face away? That do everybody a favor. There we go. So yeah, you should be able to take everything that you learn in this course and bring it to all kinds of circumstances in which you are programming with different programming languages, or even just thinking in a structured way about stuff that is not programming. So, and most of engineering should benefit from your ability to do these things. So we do use software to do incredibly complex things in the modern world. People build self-driving cars. At Memorial, they're more into self-driving submarines here. Things like building simulators that help train ships' crews in how to get out in an emergency or fight an emergency or that kind of thing. We use software to do things like secure networks, which is my own kind of research is related to computer security and privacy. And software is incredibly sophisticated, and we can use it to solve all kinds of problems. So how are we going to do that? Well, we are going to take a bunch of tools and we are going to put them into your engineering programming toolbox. So what kinds of tools are we going to put in that toolbox? We're going to use logic. We're going to teach you about computation. We are going to teach you about data types, and we're going to teach you about something called imperative programming. Now, what do I mean by imperative programming? Well, does anybody know what the imperative tense means in natural language? Any thoughts about the imperative tense? Well, the imperative tense is like when I say, do your homework, right? I give a command, and that's the kind of programming that we're going to do. We are going to tell the computer to do things. We are going to say, do this, and then do this, and then do this, and then do this. And then sometimes go back and do this stuff again, and go back and do it again, and go back and do it again, until something happens, at which point I want you to do this instead, and do this, 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 again, and again. That's the kind of programming we're going to do, and it's called imperative programming. And we are going to do it in a programming language called Python. So when you learn music, you learn a lot of music theory. But theory is not much good by itself if you don't put it into practice, right? So you learn musical theory, but then you can express that theory on a piano or on a violin or on a guitar or on a bass or on drums or whatever. You can express that theory in lots of ways. And you can sort of understand theory and have it in your head, but until you can really spend lots of time practicing on your instrument and putting that theory into practice, that theory is just kind of in your head. And so practice helps move the theory from the head to your gut, or some people say from your head to your heart. And so similarly, just like to really master music, you need to not just sit in a class and listen to somebody talk about the Neapolitan Sixth. You need to go lock yourself in a practice room and dedicate yourself to practice. Similarly, to do almost anything well, you need to not just listen, but you need to do. And so we need a vehicle that we are going to use to express the things that we are learning. In this course, we'll use a programming language called Python. Now, Python is a great little language. It's actually it's really simple to learn some parts of Python, but it also has lots and lots of depth that you can go into. And it's actually one of my go-to languages. There's like 3 or 4 different programming languages that, depending on what I'm doing, I will reach for and take off the shelf first. And Python's actually one of them. It's a great language. It has lots of depth, but it is also really accessible. And we can start with really, really simple things. So, yeah, here we go. So let's write some Python. And I bet you can tell me what this Python is going to do. I'm going to type 1 + 1, and I'm going to press enter. And what do you think it's going to do when I press enter? It's going to report something back to me. And the thing it's going to report back is the number 2. Surprise! Right? Okay, so maybe that's not actually a whole lot of Python that we've been able to use thus far, but it is, in fact, a real Python expression. And we are going to start from things you already know about mathematics and use that to kind of ease our way into learning more and more stuff about this programming language. And it is fantastic that we are able to leverage what we already know to start on a nice smooth progression into Python. Yeah, next time I'm going to have to modify the buffering settings because apparently it's taking a few, yeah, that was quite a few seconds before the 2's started appearing, but yes, absolutely. Okay, so here's how you succeed in the course. And a good way to succeed in this course, I mean, everybody wants to know, how do I do well? Well, the answer is kind of going to be, in a general way, the same as for any course, but there are also going to be more specific things. So in general, if you want to succeed in a course, you engage actively. So there's a really, unfortunately, somewhat common way to do poorly in this course or in any other course. And the way to do poorly is to show up at the lectures, or, you know, in this case, I guess, open your phone or open your computer to look at the lectures, just sort of hear what I'm saying, be passive consumer people, not really trying any of the things that I suggest you do, not doing the exercises that I give you, not spending time reviewing, not spending time trying to put the theory into practice, but just sitting there and passively listening like a lump on a log. And also, when we get to the point of having lab partners, letting your lab partner do it instead of you doing it yourself to gain the understanding. If you do that, that's a really good way to underperform in the course. So the value you get out of this course will be dependent on the effort that you put into it. So if you actively engage and do the things that you should do, you will get a lot more out of the course. So in the notes, I said the value you get out of this course will be proportional to the effort you put in to explore and understand the material. So it's not just about the things that I tell you to do, though I will give you lots of suggestions of exercises you can try. It's also about having allowing yourself to have an inquisitive mind and just do some exploration. I wonder what would happen if I tried this, that, something else. But here are some specific things you ought to do. Try stuff out. So by the end of this lecture, I will have mentioned where you can get the Python interpreter that I just showed you a moment ago, this thing called Thonny, which is right here on the right side of my screen. I will have showed you where to get that, or at least I'll pointed you where to get it. You should get that, and you should try typing 1 + 1 and see if it says 2 in it. And then try a few different things. Allow yourself to explore. So run the same stuff that I do. Run slightly different versions of the things that I run. Run things that are completely different, that you're just making up, and just see, I wonder if this will work. So whenever I show you exercises or whenever I show you examples, take them and run with them. Pardon the pun. One way or another. If I show you a solution to a problem, try to find a different solution to the problem, or try to forget what I said and do it yourself just to gauge your own understanding of the material. So try stuff out. And practice, practice, practice. The more you do, the better you will master it. It's not for almost any course, you can sort of kind of get it a little bit, or you can really make an effort to master it. And if you really make an effort to master it, you will build yourself a solid foundation for whatever comes next, whether it's computer engineering or something completely different. Mastering any first year material is going to put you on the solid footing for what you do next. So lots of things about engineering, and software design is definitely in this category. There's a science to it and there's an art to it. And so we're going to teach you how to design solutions to problems using programs. But you can't say that you've really figured out how to do it unless you do it, unless you try it yourself. So when I give you exercises and examples and things, take them and practice with them. On the course website, which at this point I guess I might as well mention, so on engi1020.ca, which is also visible through Brightspace, you'll see there's a resources section, and in the resources section there's a tools page, and in that tools page you'll see things like, here's an online tool that you can use to interpret Python, and so REPL.IT, online GDB, but also there is, so I've suggested you might want to start there, start by something you don't have to install anything, just go to a web page, start typing in Python, and it gives you results. But also there's a tool here called Thonny, which is the tool that I was showing you just a minute ago. And it's a great little tool, really quick and easy to install, self-contained. It's not complicated at all. And using that tool can help you explore and put things into practice. This week, you should make sure that you are comfortable opening and using at least one of the suggested tools from that page on the course website. Another thing that will really help you succeed is to ask questions. Ask yourself questions, ask your peers questions, but also ask me questions. I am approachable, well, I try to be approachable and to answer questions and to treat all students with respect and to not make fun of you for asking a question about something that you're only learning, right? I'm not going to be like mean because you're asking a question that is something that I learned 20 years ago. You're just learning it for the first time. So of course you should have questions. If you have a question, there's a good chance there's another 20 people in the class who have the same question, but they just might not want to speak up or ask about it. Hopefully Top Hat will make that easier because we're going to have opportunities to ask questions, and in some cases your peers won't be able to see even who asked them. And in some cases I won't even see who asked them. Unless I need to. If people say things in the platform that are like abusive, I can figure out who said what. But in a lot of cases, I, by default, don't see who asked a question. And there are probably lots of other people who are wondering the same thing. So ask questions. You should, as you are practicing, work together, but also work independently. So there are going to be things in this course that you do with your peers. When I give you an example, and I say, now take that and go run with it, you can do that yourself, but you can also do it with your friends and, talk about how does this work? Why does this work? What do you think this is? What do you think it will do if I type this into Thonny and press enter? Well, what do you think we'll do? Oh, we think something different. Well, let's see which one's right. Okay, why did it come out as this as opposed to that? So you can do those things together. We're going to have exercises in this course that I give you where I'll say, please submit an answer for this. And I'm not going to mark whether it's right or wrong. I just want to know that you did the exercise. For those kinds of things, work together by all means. You also should work independently. At least some of the time, you should practice by yourself. At least some of the time, you should take an exercise and see if you can do it all by yourself, not following along with me, not following along with a friend, but just try it yourself. And then there are going to be other things that you have to do by yourself. So assignments are independent work. Obviously, exams are independent work. So you should have a combination of working together and working individually. Oh, I see some people are typing questions in the YouTube chat as well. Okay, yeah, that's fine. Yeah, somebody said, can I use Spider as an IDE? Yeah, absolutely. If you have a different integrated development environment that you already like, then that's fine. Use that. All right, so how are we going to help you succeed? So first of all, what resources are we going to give you that will help with your success? So there is the course website, which I mentioned, engi1020.ca. You can also get to it through Brightspace, but sometimes Brightspace is known to cause problems sometimes. So, sometimes you may have more success just going to engi1020.ca. There is a book that is like recommended as a useful book, but it's optional. So there's no mandatory textbook in this course. But this book by Gutag is actually quite good. There are some textbooks out there, and I know some of them are a racket. There are people who publish a new edition every year, and the only thing they've changed is like the ordering of the questions and nonsense like that. They just needed, I need an extension on my kitchen, so I guess I'll publish a new edition. There are some publishers like that, and they're a bit of a racket. But then there are some who are actually good, and this is actually a pretty good book, and not very expensive. The thing that is mandatory for this course, instead of a textbook, is a lab kit, for one thing. So this device, let me see if I can hold that up here. This is called the Grove Beginner Kit. It used to be that we would have students buy... Sorry, this box is hard to open. It used to be that we would have students buy a device that looks like this and a kit that looks like this, and you'd put a bunch of things together, and that costs somewhere in the neighborhood of $100. These days, we have an all-in-one kit that you can use, and oh look, it even has a very friendly message that says, "Welcome to ENGI 1020. Hooray! That device is like $40-something at the bookstore, and we do need you to buy it and to bring it to the lab. You'll also be able to keep it when you're done, because it turns out that this little kit, well, you're going to be able to plug all kinds of sensors and actuators and things into it, and a bunch of students go on to use this kind of thing in subsequent projects and stuff. So, you're going to keep it and use it, but you're definitely going to use it in this course. So that is mandatory. The other thing that you have to do, so you should have now received emails from 2 online resources. One is called Gradescope. That one doesn't cost anything, but you have to be registered for it. Well, it does cost something, but the university is paying for it. The other one is a thing called Top Hat, which, well, I guess a lot of people are using right now because I'm talking to you through Top Hat chat. Top Hat is going to allow us to be very interactive, where I can ask you questions and things. And that is something that you do need to subscribe to. Now, I'm not an expert on the subscription models of Top Hat. I know there's like a per course subscription, and I think they have like a per semester or per year or something. I can't answer those kinds of questions, but I'm sure that their support people would be happy to. But Top Hat, so you don't have to buy a book in this course, but you have to buy the lab kit, and you have to pay for a Top Hat subscription. I think they have a 2-week free trial or something at first, but we are going to use it throughout the whole course. And so Gradescope and Top Hat are also both linked from Brightspace. If you don't have access to either of those, do let me know. Someone had a question. If you already have the old kit, can you still use it? So that is an interesting question. We're trying to figure out the answer to it. Some of the stuff that we are going to do in the lab will work on the old kit, but some may not. So we are trying to figure out whether or not or to the degree to which we can accommodate students who have the old kit in the context of a lab that's really designed for the new kit. At this moment, I don't have a clear answer for you on whether or not you'll be able to use the old kit. It may be something like maybe you can even use it for some of the labs, but not others. Once we have a clearer answer, I'll give it to you. But in the meantime, I would suggest just getting the new kit. It's, compared to the cost of like textbooks in a lot of courses, it's really not a lot of money. All right. Speaking of Top Hat, let me ask you something else that I am curious about. No, I don't want that full screen. So give me one word. Please make it a word that is suitable for presentation on a screen. But give me one word that describes your perception of computer programming. Oh, people are thinking very carefully about this one. Okay, we're starting to get some answers now. So I'll give us another, say, 30 seconds maybe. One word describes how your perception, how you think about computer programming, what you think computer programming is or what it's like. And again, please make it a word that I'm not going to be embarrassed to show on my screen here in a moment. Once again, this is one of these things where by default I don't see who said what, but if you say something shocking and abusive, then I can find out who said it. All right, so let's call that enough time. I'll give it just a couple more seconds, actually. 5, 4, 3, 2, 1. And all right, let's close that and look at the responses. Okay, so complicated and complex. Okay, there are degrees to which it can be complicated, but it doesn't have to be. So we're going to show you some very, very simple things to start with. And if you can master the simple things, then we will teach you how to master putting some simple things together and then some more simple things together. And then over time, actually, you'll learn how to do pretty complicated things with building blocks that are individually pretty simple. It's logical. Yep. There are commands. Yes. So this is imperative programming. We're telling the computer, do this, do this, do this. It's magic. Sometimes it almost seems magical. What is it? Arthur C. Clarke, who said any sufficiently advanced technology is indistinguishable from magic. So some of your friends may think you're a magician by the time we're done this for the stuff that you're going to be able to do. Interesting, logic, fun, confusing. Yeah, maybe confusing for some at the moment, but hopefully it won't be so confusing by the time we're done. Uncertain, yeah, that's fair, but we are going to try to give you more certainty over time. Okay, so those are some of the resources we're going to give you to help you learn things about programming, but there's also human resources. So I'm going to have an office hour. Now, office hours are a bit funny at the moment. So what I'm going to do for office hours right now on Wednesdays at 4 is, I'm going to use a WebEx link, and this is the WebEx link that you can use to meet me in my office. However, certainly the hope is that we'll get back to a place where we're doing a lot more stuff in person, and actually you'll be able to come by my office on Wednesdays at 4. I'm in CSF 4123, and of course if that specific time doesn't work, then you can always send me an email and let me know. So Ms. Lori Hogan is the lab instructor, and her email is in the course outline as well, which I will show you in a couple of minutes, but it's lehogan@mun.ca, and you can contact her about anything to do with the lab. And I see a couple of people already in the chat had lab kit questions, and it looks like Lori's already reached out and said, why don't you contact by email? So that's great. There's also the Engineering One Success Center, which is it is a physical place in the engineering building, but it's also, they're offering virtual and online things at the moment. So the Engineering One Success Center has tutors who during different times are available to answer questions and help you understand things. And also there's a supplemental instruction leader, an SI leader named Tasneem, and you'll get to meet her on Wednesday. So there are lots of people. Plus, you're going to meet some very, very friendly and helpful TAs when you come to the lab. There are lots of people who are here, and we are invested in you succeeding. But ultimately, you have to be invested too. So if you need help, please don't hesitate to reach out, because we would love to be there and help support you as you figure out all of this, online learning stuff and programming. So, what are some things that you need to do today? Remember where I said we're going to do some active learning? Or you need to have active engagement. Well, this is what active engagement is going to look like. On day one, I'm giving you stuff to do. Do it. So you need to check and make sure that you can access Brightspace. So you should have a course shell for this course in Brightspace. You should have access to Gradescope. So you should have received an email from Gradescope that said, you've been added to this course. Check and make sure that you can access that, because that's going to be important. And also, you should make sure that you're able to access Top Hat, because we're going to use this during the lectures for interactive response, and I'm also going to assign a little bit of homework for it. And in fact, I'm going to assign you a piece of homework in Top Hat today, which will be due by the end of the week. Now, it's not going to be very complicated homework. It's not going to be, actually, maybe I'll make it on Monday because give you the weekend to reflect as well. It's not going to be a very complicated piece of homework. It's going to be thinking about where are the computers around you in your life that don't look like computers, just so we can think about just how pervasive computing really is. So today, I want you to check and see if you can access Brightscope, Brightspace and Gradescope and Top Hat. And if you can't access those, let me know today. So I did also mention that we have, so the course website is something that you can see lots of these things. I mentioned on the resources page, the tools page, which will show you various tools that you can use for running Python. So you can get a hold of one of those, like, for example, Thonny. And then you can do stuff like running 1 + 1 and see if it gives you 2, and then try some other stuff too. But also on that page, we have the documents page, which includes the course outline. And so this course outline is something that contains lots of important information. It includes information about the course, about the things you're expected to learn in the course. It also includes things about evaluation, how the assignments and the labs and the project are going to work. We will give you more detail about that project over time. So by the end of the course, we will hopefully be able to be back in a situation where we can have people paired up and you and a partner will work on a project to design something of your own choosing and to have fun with that. And also some information about the key topics in this course. Also, reiterating some of those things about the Student Success Center, and also a couple of things about COVID-19. So we do hope to get back to, so we're going to have in-person labs starting next week, assuming all the technology in the computer lab works, which is, at the moment we're almost there. But also we hope to come back to in-person lectures in February. We'll see for a large course like this, maybe, maybe not. But I would definitely, there's a reminder that Memorial has some policies that are relevant. There's mandatory mask policy and a vaccination policy. Also, I'd really, really encourage everyone to download the COVID Alert app. No matter what Minister Haggie says, the COVID Alert app is not actually dead, and it's something that could be really, really important once we have a whole bunch of people sitting in a room together again, whether it's in a lab setting or a lecture setting. The COVID Alert app, so I'm a privacy and security researcher, and I'm quite cynical about privacy and security things. So hear me when I say that the COVID Alert app has like the best privacy properties of basically any app on my phone. That's pretty good. I'm very privacy conscious, but the COVID Alert app is fantastic. It doesn't even know my name. It doesn't know where I am. It doesn't know anything. All we have are these random codes that are being auto-generated, which are not linkable to you as a person. So it could be really helpful if we get into a situation where somebody in a lab has contact tracing or has COVID and we don't want it to spread through the entire university before we find out through traditional phone-based contact tracing. So do consider installing that app. It's not mandatory. It's a free country. We can't make you install things on your phone. However, I would really ask you to consider that. And there's lots of other really, really important stuff here about assistance and equity and academic integrity. This stuff really is important. So the course outline is only 3 pages. Please do read those 3 pages. We also here reiterate some of this information about where to find people and links and stuff. But yeah, so, and also we have a link to the chat, which you should be able to see right now. So I'll go to the questions now. And so let's see, are there any gap notes for this course, or should I just grab a line notebook to take notes? Well, I mean, note-taking style is a very personal thing, and so it's completely up to you. For myself, I have to write things down, or else I won't remember them nearly as well. And I know for a lot of people, well, the action of writing, it's not just me, the action of writing does improve retention. For some people, it's fine if they just write in like gap notes, and for some people, writing the whole thing out and figuring out how to organize it is better. So I'm never going to tell you what way to take notes. Figure out what works well for you. However, I am going to upload some pages that have, and so if you go to the lecture section of the course website, you will see PDFs that have, here's a slide, and here's some gap notes. And so you can do this, you can use those gap notes, or alternatively, you can write it yourself in your own notebook, whether it's on paper or electronically, whatever works better for you. All right, are there other questions? Anything else anybody would like to know? Right. Well, we're coming up to 11:50, so please do read that course outline. Please do make sure that you have access to all of those services and things that you need to have access to. And if you don't have access to anything you're supposed to have access to, let me know today so that we can get that problem solved for you. Yeah, so it has been great chatting with you. I mean, unfortunately, it's texting, and I really do look forward to actually seeing your faces and having a little more human interaction. But for the moment, it's been great having at least these text exchanges online. I might even stick around in the chat for a few minutes and answer questions that way. But at this point, we are going to end our lecture. So have a lovely rest of your day.